Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, in this video we are going to go over the parts that I've collected to put together this second monoblock, and one or two things that we're going to be updating on the previous one. That's kind of the final deal, and kind of show you how this is assembled and where all the parts go. So, not a lot of reason to talk about this. Let's get busy. Okay, so let's go over the parts that we're going to be putting inside these monoblocks. And first of all, here is a huge pile of resistors, and all the resistors I'm going to be using are 2-watt V-shaped metal film, the PRO2 prefix resistors. I really like these. They're nice and quiet. They do a great job. They're compact for their wattage dissipation, and being a larger size resistor makes them even quieter. And several websites on the internet that talk about this, that like oversizing the wattage, they have less noise. The other thing we have is we're going to be using a 4007 diode for the bias supply. So we're going to need one of those. The only resistor that's going to be different is this little guy here, which is our 10 ohm, and it's a 0.1%. It's going to be on the cathode, and we want a high precision resistor there because this is the shunt that we're using to measure the bias current. And it's important that this be a precision resistor so that we get even bias or an accurate measurement. Okay, have our little RCA jacks. I like these kind like this that have the little tab that you solder directly onto the RCA jack body. We got a red and a black one. And you can use whatever you want there. I got some of these speaker jacks, which I thought looked really nice. Again, you can use whatever style you like. You're going to need a little ground plug for connecting the safety ground to the chassis. Going to need an IC connector. Going to need 2 8-pins and a 9-pin. And like for the rectifier tube, the pins that I'm not using, I just cut them off and bend them over like that. And I'll do the same on this socket, the pins we're not using. And I think we're using all the pins on the 9-pin, but if not, we'll do the same thing there. Here's our bias pot. I like this one that I got from Yoda Electronics. It has a lock nut so that once you set the bias, you can tighten this down and it crimps the edges on the shaft so that it can't move. Here's a couple of test point jacks. Again, there's multiple different versions of these little guys. I just like these because they were metal. Then we have our power switch. I got this off Amazon. It's a latching on off. It's got a angel eye LED. This one's yellow. The Amazon one actually came with a little harness, which is nice. I also use one of these NTE 5332 bridge rectifiers across the 6.3 volt heater winding to convert the AC to DC for this illumination light. And then I also put a low voltage, I can't remember, I think it's a 330 UF cap across the output of this to filter it. The reason I do that is I want to make sure that this LED lasts as long as possible. And by sending filtered DC to the LED, it ensures this isn't going to burn out prematurely. I also drop the voltage going to it with, I think it's a 33K, but I'll put it in the BOM, that dims this down a little bit so it's not so in your face bright. Okay, so there's that stuff. We'll get into the hardware here in a minute. But part of the hardware, well, we go and do the hardware now. We've got these trim rings, and on these, you can see the tube socket lines up with those two holes like that. And then on this smaller one, the same deal. Tube socket lines up with those two holes. Then you don't have any visible nuts or bolts on the top. The trim rings act as the retainer on the top side of the chassis. Now you will have to get a Dremel tool and slot these holes a little bit on both of these to get the holes to line up with the screw holes in these trim rings. And then this one, it's got 4 holes, and it goes around the perimeter of the cooling holes on the top plate for the tube. And again, these are very optional. It's total dress-up items. You can just use screws and nuts if you want to save a little money or just save a little hassle trying to line these up perfectly and just bolt them down with the slots that these sockets come with. So the next is we're going to have an assortment of hardware, obviously. The main ones are, we have long and short 5mm, and I'm using cheesehead screws, but you could use whatever you want. I thought these matched kind of the theme of the Phillips head screws that are holding the end bells on the transformers, and they are silver, so they match the, obviously the silver theme that we're kind of going with this. But the key here is you've got a short one and a long one. The long ones are doing double duty, holding down things like these clamps, so we don't have extra holes in the top plate. And then also some of the holes are threaded into those side beams in the chassis that I'm using. And so again, it's basically half of them are long and half of them are short. So the other thing we have are these little, I call them Adel clamps, but they, insulated clamps, whatever you want to call them. And they're actually 3 different sizes to fit the 3 different diameter capacitors. And so I wanted to use these to securely mount the capacitors to the underside of the chassis. Plus it just looks much neater, which we'll see in a minute when we start looking at the underside of the finished amp as a guide to how we're going to be doing this thing. Then we have a couple of 100 volt, 100 UF caps. I went with bipolar ones, and you could use polarized ones, but I just decided to go with these bipolar ones because they're normally cleaner sounding than the polarized caps are. The other thing you're going to need is an XY safety cap to put across the power switch, and this is mainly to get rid of a pop noise when you turn on and off the power. And you do want to use these XY safety ones because they're designed that in case they do have an issue, it's not going to cause a safety hazard. Here's our Mundorf 0.33 UF coupling cap. It goes between the driver tube and the output tube. Okay, so then we have our tag strips, and as you can see, we have 3 different kinds. We got 2 of these 5 position with the center lug, and then we have one here with the ground lug on one end and the other with the ground lug on the other end. If you had them all of one kind, what I have done is just bend this one over 180 degrees to make the mirror of it. But when I was ordering up tag strips for just to have in stock here for my projects, I ordered a variety of different ones. So if you have to buy 5 of these to get the minimum quantity, you could just buy like one version and then flip the little tab over to make what you need. Okay, and then obviously we have the iron. This is the power transformer. It's a 800 volt center tapped, and this is a 375X. Now, we get a lot of confusion or people sending me emails. Well, I live in Europe and we have 220 volt, and how much of this do we have to change all the components inside? The only thing difference in the different countries with the different voltages is going to be the power transformer, and it's only on the primary side of the winding that's going to be different. Everything after that like from the secondary winding on through the amp. All the voltages are the same, all the parts are the same. The only thing that changes is the primary. And on some of my projects, I use the 200 series, which would be like a 275X, would be the Hammond number. Well, in this case, I'm using a 375 because I needed the bias tap, this 50 volt tap for the bias supply. And so these 300 series normally come with a bias tap. They come with a shield that's grounded to the end bell, and then they also have multi-voltage primary windings. And so you can wire this up for 120 volts, for 110 volts, for 230, for 240. All the different voltages are capable of being wired up by using the various leads that come out of this transformer. The other thing that I've started doing is the wires that I don't need. If there's like extra taps or leads or center taps and stuff that I'm not going to be using in my project, I cut them off short and then double insulate it with 2 wraps of heat shrink tubing and leave them inside the end bell so they aren't pulled inside the amplifier and look messy. And so there were extra primary leads, and I think there was a center tap for the 5 volt we weren't using that I insulated off and left inside the end bell so we wouldn't just have extra wires inside the amp. But obviously, if you don't want to do that, you can pull them inside, insulate them inside the amp. Since I was pulling these apart to paint them white to match the Thermionic Labs output transformer, I decided to go ahead and do that. Okay, here's the choke. It's a 193H 5 Henry 200 milliamp. Goes on the top plate, and again, I painted the end bells to match the output transformer because they did tell me don't take the screws out of this. For whatever reason, they said it could mess up the gap. So I listened to their instructions and I left that alone. And this top mounted choke is rated, I believe, 600 volts, which is plenty for this amp. Then we have obviously this output transformer that comes from our friends Thermionic Labs that donated this to the channel for me to do this build, so I really appreciate them doing that. So far I'm really impressed with the quality and the way these things sound, but I need to finish up the second monoblock and hook them up in stereo and really spend some time listening to them before I give my complete subjective review on them. But so far I'm very impressed with the quality of their products. So here we come up to something that's a tad bit controversial, and that's the internal choke. And someone pointed out these are only rated by Hammond for 400 volts. And this is a 200 milliamp 2 Henry choke. It's a nice compact size, and I've been running one of these in my 300B amp for a couple of years now and have had 0 problems, and they have 430 volts running through them on that amp. And so I'm more concerned about this milliamp rating than I am the voltage rating. And I know Hammond probably would say, don't listen to Skunky, but if you really feel this is sketchy, you can put something like this 159V or one of these other 500 volt rated chokes. You can see how much larger they are. I mean, they're over twice the size, and when you look at the height too, these are giant chokes. And there just really wasn't room inside this chassis to comfortably put a choke this size in. So, if you're going to use these giant internal chokes, you probably want to put a little bit bigger chassis than what I'm using to make room for this big guy. These also have a little bit lower DCR, especially this 1.5 Henry one, and it's close enough this 2 Henry to do the filtering, and that'll give you a little more B+. But I personally feel comfortable using these, 157R type chokes. And again, I've been running one for a couple of years. I think there's a pair of them in my 300B amp that have been running at, way over 400 volts for a long time, had no issues with them. And I feel like too that with an over amperage, if you were pulling more amps than they were designed for, you could end up with them overheating and potentially this stuff catching on fire, something crazy happening. But I feel like when you're overvolting them, the worst thing that can happen is they arc and will blow the fuse, and then you go, okay, that didn't work. So let me show you what the inside of the amp looks like and where all these parts are laid out, and then I'm going to start assembling this thing so that we can start wiring this up and get this second monoblock built. So this is what the inside of the finished amp looks like, and we'll kind of start on this end and just go across the amp. So the 157R choke is bolted to the back of the amplifier, and then you can't really see it, but the speaker jacks are over here on this side. We kind of slide it down so you can see where those are. You can see they're here and here. And then over on this corner we have the IEC connector. You can see the wires from it up inside here. And then we have the safety ground and the lug up here in this corner right up here next to the ground lug. Okay, so we'll work our way across the amp. This tag strip down here is used for the heater wires to come up and connect here to give us a point to connect the stranded wires from the transformer to these solid core wires that you can see run up along this edge here, and then they come up here to the front and across here in the front and then over to the driver tube. So we got the heater wires twisted up tight and run along the perimeter of the chassis to keep them away from the signal wires, and that way we don't have any problem running AC heaters and don't have to mess with rectifying and putting DC heaters. And I think a lot of people think you need DC heaters because they don't know how to correctly lay out the wiring for the heaters so that you don't have issues. So the other function of this tag strip back here is we have this lead here, which is the 50 volt tap off of the transformer, goes through this diode, and here's one of our 100 UF 100 volt bipolar caps that filter the bias supply. Then this wire comes up here, and this is our bias supply voltage wire. We have a couple of resistors here that are part of the bias supply, and then this is the other 100 volt 100 UF bipolar cap that's the second filtering cap for the bias supply. This tag strip up here also gives us a point to connect the bias potentiometer for adjusting our bias point. And then finally, the output of this little bias circuit comes up here to the white wire. There's our grid leak resistor, and it goes to the bias through the grid stopper. We also have the coupling cap hooked up to this point on the tag strip as well that goes over here to the driver tube plate. Okay, so let's get into the power supply. This is our star ground point. This is where all of our grounds are brought to, and I've tied these two pins together with a fairly large wire down here on the tag strip, so we have two ground points that we can use to bring all of our grounds to. So here's our rectifier tube. The high voltage AC comes over to these two pins. These yellow wires are the 5 volt heaters, which means this pin 8 is the output of the rectifier tube. So we have, this is the first cap in the filtering for the power supply. So this wire comes across here to this side of the cap, and then This side comes over here to ground. The top side choke, that's the wire going to it. So it goes to the choke on the top side of the chassis, and then it comes over here to this side, the positive of this second filtering cap, and then this green wire is the other ground. So the internal choke then connects here. The other side of the internal choke is connected here. Here's our ground for that cap, and this is our filtered B+ or high voltage DC. And then that voltage comes down this red wire and comes over to this terminal on this tag strip. We hook up the positive lead for the output transformer right here. And then the other two wires come over here to the plate and the screen, with the screen resistor soldered into the end of this wire with a little heat shrink tubing. So this wire right here is our shade feedback. It comes over from the plate of the driver tube up and over, and then the resistors soldered into the end of it. And I still need to put some heat shrink tubing over that resistor. So then we have the dropping resistor for the driver tube, and then this is the filter cap for the driver stage. I did order a pair of 600 volt caps for this position because this at 500 volts is really pushing the voltage rating of this cap, especially on startup. And I know I talked previously about the voltage rating on this choke, and while I'm not super concerned about pushing a little past what this is rated for, caps is always a no-no. That's what blows them up, is going over their voltage. So I'm going to be replacing this with a 600 volt 33 UF cap. So over here, and I'm not going to go into all the detail of this, but these are all the resistors that hook up to the plate and triode strapping the 6EJ7. And here's our RCA jack. And you can see I didn't bother with using shielded cable from the RCA jack to the tag strip because it's about an inch long. And that's one of the reasons that I like this layout where the RCA jack's on the top, is that it keeps the internal low signal wiring super short and you don't have to worry about it picking up noise. So over here we have our little bridge rectifier that goes across the 6.3 volt heater terminals on this tube, and this is doing the filtered DC that goes to the illumination LED. And there's a little cap sitting right here that I've kind of glued to the chassis. Just kind of soldered all this stuff together. And then there's a resistor in line, and then these come over here to the LED on the power switch, and then the other side of the power switch comes over here and goes back to the transformer. As you can see, we're using these screws that hold these tube rings for the tag strip mounting points. Like this tag strip's mounted to that screw on the tube socket, and the same over here. This tag strip's mounted to the rectifier tube socket. Here are our long bolts holding the transformers down that we put washers and these shoulder nuts on to hold these clamps for the capacitors so that they don't have any exposed hardware. And then this is the screw that we drilled the hole for underneath the power transformer to mount this tag strip so that hardware is not visible. And we can have a point back here to wire this stuff up. Here's the last part I didn't go over. Here's our 10 ohm cathode resistor that's the shunt for the meter. And you can see the two test jacks are up here in the front, and then the wires for them, this one goes to the ground, and then this one goes to the cathode of the output tube ahead of this resistor. So anyways, looks like a good place to wrap up this video. Well, I hope that helps y'all understand kind of how this thing's put together. And I think before the next video, I'm going to go ahead and bolt down the iron and install the caps and not do any of the wiring, but get like all the components laid out inside where we're going to be putting them. And then I can show y'all step by step how to go through the schematic and follow the schematic as you're going through soldering everything, so that you understand where things are going and how the current's flowing through the amp in case you ever have to do any diagnostics in the future. I know some people want to build something like this and they don't want to understand any of the theory. They don't really, it's like can't read a schematic and I don't care about it. I'm going to try to help y'all understand how to read schematics, and I don't want you just putting this thing together and then mailing me pictures of your tag strips and say, does this go on the second or the third point in the tag strip, and which lead of this capacitor goes where. You need to be able to figure that out yourself, because if you don't, you're going to have problems in the future, and that's not really how I want to be teaching folks to build stuff, doing this kind of, step by step, just put the wire on the right tag strip and it'll work, and you don't need to understand where it's going. I don't think that's really the way that you should be building this stuff. Especially if you have a problem and you're done, then I get to figure out this for you, and that's not what I'm trying to do here. I'm trying to teach you how to understand what you're doing while you're doing this. And so, anyway, hope that doesn't sound rude, but I really think that it's important that you understand what you're doing here. So anyway, I hope you're enjoying the series. If you are, please subscribe to the channel. Please like the video. Thanks all you folks that are Patreon subscribers. That's a huge help, as is the donations to the website. Helps me afford to do projects like this. So anyway, we should have this assembled and have the next video up fairly soon. And until then, have a nice day.